Good afternoon, friends. So we are today just going to complete this filtration. We saw yesterday sand filters, rapid sand filter and slow sand filter. I hope you went through that link, and that gives a lot of information not only about the process but also the benefits, demerits, and all the things. Here, yesterday I made a slight mistake in my lecture. I was going reviewing my video. I told that the thing is rotating very slowly. It's actually a operator's platform. This is a settling basin. Okay. So if it is a flocculation basin or something, probably you will have something rotating and all that. And this is not that sort of a thing. This is just a platform which you use to come to the center of the tank. Please remember this has the inlet from the center. I think in that cross section you saw, no? So the inlet is from the center and then it flows towards the periphery. As it flows, what happens? The solid starts to settle in a pattern, and also the base is sloped. It's sloped towards the center, so you can have a scraper at the bottom if required to scrape all the scum into the place where it can be washed out. Okay, so that's a sludge collection mechanism there. But basically, the water as it flows will have the solids settle. So you have a higher depth at the middle. So large particles can immediately settle. Smaller particles might go to the side, but again you have slope so that all the particles can be brought back to the center. Okay. So I just wanted to revisit this slide in particular. So filtration, we have granular filters. All your sand filters are also basically granular materials only. So besides this, we can use other granular materials. And now, of late, earlier there was only sand filter. The rapid sand filter was a improvement over the slow sand or traditional conventional sand filter. Traditional sand filter, there is no gradation of sand. You just put fine sand, let the water run through. So here you have some gradation. So because of the gradation, excuse me, I'll just turn off my mic, right? So because of that gradation, you're going to find that there is an increase in the flow rate. Okay, then we also saw about the pressurized systems where you can apply pressure and send it. Okay. Now these filters are getting slowly replaced by other filters, and some of them are this where you use coarse anthracite coal. Okay, and then you have coal, silica sand, and garnet sand. Okay, all these are newer materials which are being used as filter medias. Then you have this diatomous earth. What happens is you fill a thin powder-like material made of diatoms. Okay, so that's the name which they give it on the surface of your bed. And the only problem with this is this material has to be replaced over a period of time. If it's not replaced, it will get all clogged up. Essentially, you just have to remove the top scum, throw it away, put new material. So, what is the problem with this method? If you are not putting this material, diatomous earth fill, the filter is not going to work at all. Nothing is there to do the filtration. Okay. So here is a screenshot of a filter bed. So essentially, initially the filtration occurs only at the surface. Now, once filtration is started, you'll find that it clogs the filter media. It's much like your tea strainer. Okay, initially you pour tea, it flows freely. Once everything starts to come, you'll find it clogging. Especially milk and cream. Okay, that is one of the best things I think. If you don't like cream in your coffee, you have to use a filter. So once cream starts to form a layer, you'll find that the milk is not flowing through the filter media. Same thing is happening here. Okay, but what happens is coagulants, they are actually quite small, no? So when the hydraulic gradient, there is a pressure difference. That gradient when that takes place, it can start to break through. Now see what has happened. It has started to penetrate into the filter media. If it filters a little bit more, what happens? It will start to flow through the bed itself. So this is one condition which is unacceptable in filtration. In other words, even if you backwash or anything, there might be a chance that this will still continue to clog the filter media. Okay, so this will be like, what can we say, a problem which is there in filtration. Okay, next we also have some parameters for filter bed design. Okay, what are the pre-treatment that you will consider for before this particular filtration? Screening. Okay, sedimentation, coagulation and flocculation. Probably you will do coagulation, flocculation, sedimentation. Okay, and then filtration, and then filter. So those pre-treatment would be required for this, or you might be choosing your filter sand media based on the size of your inlet material. Suppose very big sizes have to be filtered and they keep very fine pores. What will happen? The detention time will decrease, increase. You're right, it increases. So same thing. So filtration rate, how much water you are expecting to come out, you will have to know, and what are the quality you want the water to be in. So these will become your filter bed design parameters. So then again, filtration rate changes water quality. Suppose I am going to require very fast filtration to take place. Again, take for instance the example of your tea strainer. If you are using a strainer with larger holes, the milk is going to flow at a rapid rate. But what will happen? There's a chance that some cream particles can go through. Same thing, instead of cream particles, you'll be having the whatever material is given. So what you expected to have been stopped. So this is the very simple example. So again, filter medium, what you are going to use, whether it's fine screen or coarse screen or a very coarse screen, that all depends on what you want. In run length, how much the length of the filter bed is going to be, and then backwash. Okay, what is this backwash? To clean the filter, what do? You send water backwards. Okay, all these were there in the videos. Okay, so you can actually see the backwash operation and all that. But what also can be done is, along with your backwash, you can also send compressed air. Okay, so all this will enhance your cleaning of the filter medium. Okay, and finally, polyelectrolytes affect filtration. Okay, what is polyelectrolytes? In the stage before this, you added coagulants. What do these coagulants do? They had some charges associated. Now, when these charged particles go in and they are in contact with the filter media, they might get attracted to the filter bed and refuse to come out also. Chance. There's a good chance. So these are some of the things which can cause trouble to your filtration process. So till now what we have seen is basically the first stage of water purification, or the raw water which has been very filthy and all sorts of stuff has been cleaned. It looks clear and it looks drinkable. It is aesthetically pleasing. Okay, so till filtration you can achieve a lot of things. Okay, now these are some of the alternate treatment processes which can be used in conjunction with all these processes we talked about. Okay, biologically active filtration, one of the things is actually we can use ozone and all these things which will kill the harmful pathogens by oxidizing them. Okay, basically it oxidizes them. Then you have ion exchange. Okay, what is this ion exchange? It is a membrane which can selectively let ions through it. Okay, for example, you want to remove chlorine, have a membrane that will absorb all the chlorine to one side, it will take care of that. It can be chromates, it can be any pollutant. In fact, industrial wastewater treatment relies heavily on ion exchanges for removing their specific pollutant, industry specific pollutants. Then adsorption, we spoke about adsorption in activated carbon. Okay, it can be as powder form or it can be in granular form. And if you are having aquaguard in your house, okay, inside they'll have one candle of activated carbon. It removes all objectionable taste, all your or things hydrogen sulfide which causes odor, all that can get absorbed on the surface of your activated charcoal. In fact, do you have aquaguard in your field at home or something like that RO? What do you do? What is the maintenance that is being done?
Usually we have to place a bottle, it runs the water through, and if we have another outlet, it comes to
That is the backwash operation. That is for the filter, primary filter which is there. Earlier we had to reverse the direction of flow and do it. Okay, this is nothing but backwash. Okay, you are doing that in your house also, maybe without knowing the thing, but that seems to be a simple operation. Now they made it even more simple. You just press a button. What essentially happens? It is backwashing. Okay, next. Okay, another thing they do is every 6 months or 3 months they'll come. That is one thing, but activated carbon they'll come, they'll wash it and boil it, and then again put it back in. Okay, so that is one. Nowadays, what they do, they are very clever. To make money, what they do, they say the whole thing has to be changed. Okay, so that's what is happening. That's a good way to make money. So what they are doing, they are making it more and more compact, reducing the useful life, and yeah. The old aquaguard, the original aquaguard, I have split it to the last bit and I reassembled it. It's a very good and it is so simple that it cannot fail. There's one UV lamp chamber, the other is the activated carbon column. So you'll see the aquaguard old one, there are two columns and one middle center box. That is the electronics that controls only the UV light. So it has one light sensor. If there's turbidity in the water, it will stop the flow. It senses only turbidity. Okay, so turbidity should be removed by the filter, which is nothing but cloth which is wound tightly. Okay, what did you tell? Yeah, second is activated carbon. So that should remove also all your coloring agents to a very large extent. Otherwise, the water is very impure, whatever is coming in. And then it goes through the UV chamber. Here again, that length of the pipe of the chamber is going to determine your contact period. What is contact period? Yes, time it is exposed. So when the flow rate is very slow, the diameter is very large. So the outlet pipe is very narrow. So if the diameter is very large, then automatically the flow rate inside that tube is very slow. So by the time the bacteria virus travels from the top to the bottom, it would have, I think it's overflow. Activated carbon will come down, then it will go up, overflow out into your cup. So that time will be sufficient to kill all the germs. Okay. Next is this aeration. Okay, what is this aeration? It is nothing but adding air. Please remember in one of the videos you saw that water is falling like a fountain. That is the simplest way to aerate. You can use something like a partial flume, or you can use whatever we talk. Except for that hydraulic jump, I don't think that might be a very appropriate thing. But you just need violent agitation to let in atmospheric air into the system. So that is one thing. And again, ozonization is also one way of aeration only. Okay, so
large cases, that type of aeration will be problem.
yeah, that would be more economical in the sense you may have such a huge aeration area and all that. Now everything is reduced. Everything gets reduced. Yeah, and aeration actually improves the taste. Okay, please remember that boiled water doesn't taste very good. Okay, so then taste and odor. Okay, these are some of the methods which are used for removing taste and odor. In fact, your manganese and this one, even fluorides removal, all of them will be taken care by all of these. Okay. Now, I don't know if I have to talk about each of these. Any of these you want a little more information? Regulation of activated carbon. Okay. Most of these, yeah, control of reservoir intake. Yesterday we were talking, at different levels, you may find that there are more plant growth. Maybe at the bottom, these plants will also cause this taste powder. These are microbes. So you might have to just take it at a reasonable level. You go too deep, temperature of water might even increase. That might not help, or even the other way around is possible depending on so many other parameters because sunlight doesn't go in. Okay, so anaerobic conditions could exist because of that also. So all these are just based on the localized thing. Yeah, KMNO4. Potassium permanganate is a very strong oxidizing agent, and coincidentally, it is also a very good sterilizing agent for drinking water. Okay, and chlorine dioxide, right? So organic material, gasoline is petrol actually. Uh, see you can use either filtration or gasoline is always lighter than water. It will float to the top. You can remove the oil like that also. Sometimes they'll add detergents, break it up, and so lot of ways are there to remove these things.
How do hydrogen sulfide be survive?
No, no, no. You should remove hydrogen sulfide. Hydrogen sulfide causes bad smell. Hydrogen sulfide, aeration, for instance. Okay? Right. Anything else? You want to have this one? Okay. So yeah, so these are some of the things. If you are aerating or oxidizing with any of these methods, and then filter, you'll remove iron and manganese. Okay, small amounts of iron and manganese are okay. Large quantities, what will the large quantities do? They'll cause.
Why is last one is of oxygen bad for us?
Come again?
Last quiz, you answer question which are which in the notes from these
Which among the following are poisonous contaminants?
Okay. So what are the? Huh?
no, this is not a poisonous contaminant. So I just get the oxygen. So
Okay.
It is not oxygen.
Okay.
I didn't give the answer as a message. So you do it. Last one is solar chloride is not good for.
Oxygen was there, huh?
Yes, sir. This is oxygen. I kept it.
Okay. Large quantities of dissolved oxygen is definitely not poisonous. I will give credit for that. I will change it. I can change the mark, don't worry. Okay. See, these things you should point out. Sometimes, due to other pressures and things like what you don't want to put also, you sometimes put and then say, okay, let me just close the test. Okay. So usually such things also happened in my strength of materials lab. One or two people came. So especially for those who pointed out, see, to find out there's a mistake itself is an art. Okay, if you are not able to find out mistake, then you don't deserve the credit in my view. So if you point it out, I'll definitely do it. Okay, thanks. So here, water softening. What is water softening? Removal of hardness causing agents. Two types of hardness are there. What are the types of hardness? Permanent hardness. Okay, I think this is because you're telling because you have EDTA method, right? In your okay. So this is it's nothing but now these are the methods. Removal by boiling is temporary hardness. Suppose it doesn't happen, you call it permanent hardness. So zeolite method, lime and lime soda process, ion exchange. These are some of the popular softening methods. Now the zeolite method, I don't know. You or all of these methods you go through. You both of them are similar only. Both are same. But see, ion exchange. You can zeolite is one of those ion exchange membranes. That's all. But nowadays, so many other membranes have come up. Okay. So yes, even I was thinking I put ion exchange and say zeolite or this one. But in any case, nowadays we have many other membranes. Membranes of today are very smart. They try to do a lot of things. Okay. And basically, ion exchange, reverse osmosis, electrodialysis, all these things are not part of your syllabus per se. Okay, but all of these are very good agents for removing all your impurities, in fact your bacteria, virus. These are also disinfection methods. Okay, so what I'll say is, in this unit what I've not specifically targeted and told is disinfection, but disinfection is something which you've seen a lot in all of these videos. What are the methods? Basically chlorination. Okay. Now this other thing like what I told, KMNO4, addition of potassium permanganate, that is also one way of disinfection. Boiling is one, and UV light is another, and so all these things, I don't know. Even ozonization is a disinfection process, disinfecting process. So I'm not specifically talking those things. Okay, but these processes like lime soda, zeolite, ion exchange is also used for other processes like removal of heavy metals and all these things. So I want you to include these also into your assignment. Okay. So with this, I'll close this lecture. I'll say thank you. And if you have any doubts in this portion, you please feel free to